Dilations. So dilations, we're going to think of the D and the I. So we're going to think a decrease, or it could increase. This is the only one of the transformations that we do that is not rigid. This one will change the size, but not the shape. It's kind of like if you've ever put a picture on Word and like grabbed a corner to make it bigger or smaller. That's what we're doing. So we're making it either bigger or smaller. So it changes the size of the original figure by multiplying. And that's the difference between translating. We're translating, we're sliding. So it's not making it bigger or smaller, it's just moving it. Where this one, when we multiply, is either going to make it bigger or smaller. And we multiply by what's called a scale factor. All right, so here's what we're going to do. We're going to read, and it's going to either give us a scale factor. It's either going to give us a scale factor, or it's going to write it in algebraic notation, and then we can, or algebraic representation, and then we can find the scale factor based on that. So what we're going to do is we have our points right here already. We have our pre-image points. To get our image points, so we have B prime, C prime, and D prime. We are going to multiply each X and Y value by the scale factor to get our image points. So I'm going to show you how this would be written algebraically. Algebraically, we start with our X and Y. It says to multiply each one by your scale factor. So this number can change, but algebraically, this is what this would look like. This says replace X with X and multiply it by 2. Replace the Y with Y, multiply it by 2. So 2 times negative 2. Now this would move to negative 4. And 1 times 2 would be at 2. That point is at negative 4, 2. A prime. B prime, 2 times 2 is 4. 2 times 1 is 2. That point is at 4, 2. There's B prime. C prime, so 2 times 2, 4. Negative 1 times 2, negative 2. So you have 4 and negative 2. That's C prime. And then D prime, we have negative 2 times 2, which is negative 4, and negative 1 times 2, which is negative 2. So if we were to connect these, we should be able to see that my image went from, my image is bigger than my pre-image. So my pre-image increased in size to get my image. So if our scale factor is bigger than 1, it's going to get bigger. If it's smaller than 1, it's going to get smaller. If it is 1, it's not going to change. If I multiplied all of these points by 1, it would be exactly the same. I would have graphed the exact same thing. But since I multiplied by 2, everything got 2 times bigger. So that's what that means. If we multiply it by a fraction, it's going to get smaller. All right, so looking at the next one. Again, it's going to give you the scale factor, and we're going to write it in our rule. So we have triangle ABC, and it says to write the algebraic rule. This says take each X value, multiply it by 1.5. This says take each Y value and multiply it by 1.5. So we start by putting A, B, and C. A is at negative 2, negative 2. B is at 2, positive 2. And C is at 4, negative 2. My rule says multiply each X and each Y by the scale factor. So I'm going to take X, which was negative 2, multiply it by 1.5. And I'll get A prime, which is negative 3, negative 3. Because both of those are negative 2. On this one, both of these are 2, so when I replace them, 1.5 or 1.5 times 2 is going to give me my B prime, which will be 3, 3. And my last one, 1.5 times 4 will give me 6. So C prime is 6, comma. And 1.5 times -2 is still -3. Again, this got bigger. It's not huge, but it is bigger. So we have -2 and -2. Just kidding, that was the original point. -3, -3. So this point is now A prime. 3 and +3. That's B prime. And C prime is 6, -3. So when we connect this, you can see that my triangle again got bigger. Now you'll notice on this one it didn't say dilate by a scale factor of 1.5. It says use the rule to dilate the shape. So in this, our rule is take each x and each y. So take this x, take y, and multiply it by 0.8. So my scale factor is 0.8. So you'll notice that these ones were all bigger than 1 and my shape got bigger. My pre-image was bigger. Right now, I'm going to multiply my pre-image points by 0.8. So this should shrink down. So we're going to take A, B, C, and D. A is at 510. B is at 1010. C is at 10.5. And D is at 5.5. All right. So now when we do this, we're going to look. We need our image points. We're going to multiply both x and y by the 0.8. So when I do 5 times 0.8, I'm going to get 4. When I do 10 times 0.8, I'm going to get 8. So this point becomes 4 and 8. You can see it's shrinking. 10 times 0.8, we already know is 8. So this would be 8, 8. B prime. And then C prime, 10 times 0.8 is 8, and 5 times 0.8 is 4. So this would become 8, 4. And my last one would become 4, 4. So my points move, but you can see my shape. Whoa, I can't draw a straight line. My shape is no longer the same size. Before I was 1, 2, 3, 4, 5 across. Now my shape is only 4 across. So I shrunk it down by 80%. Or I made it 80%. I shrunk it down by 20%. All right. Let's look at our scale factor. So this is taking it, using the scale factor, and changing the shape. On these ones, we're going to have to find the scale factor. So things that we need to know about the scale factor. A scale factor is a ratio, so a fraction or a ratio of corresponding sides. So to find these, we're going to set it up as image over pre-image. And this is what we were talking about. If the scale factor is greater than 1, it's going to increase the figure. If the scale factor is less than 1, it will decrease the size. And if it is 1, it's going to do nothing. It will stay the same. So here's our steps to finding the scale factor. So we can see that we have pre-image and we have image. We need to figure out what they did to get from one to the other. So first thing I'm going to do is write my pre-image points. Remember, our pre-image is a nice clean copy. So we have Q, R, S, and then T. So point R is at 2, 1. We will find our prime in just a minute. And our prime was at 5, and it looks like 2.5. S was at 2 and 4. S prime was at 5 and 10. And T was at 4 and 1. And T prime was at 10 and looks like 2.5. Now, I can check to see if that 2.5 is right. And this is how we're going to figure out our scale factor. So we can see that we did something to get from 2 to 5. We can see that we did something to get from 1 to 2.5. So that's what we're going to be looking at. What did I do? So you're going to choose any point, any vertex. So any corner or point on that shape. Then you're going to choose either the x or the y value. It does not matter which one you choose. So I'm just going to choose, s. So I want to do s prime over s. And out of my s, it does not matter. I'm going to show you that it won't matter. I'm going to show you x, so x prime over x, and then I'll show you y prime over y. And you'll see that we're still going to get the same answer. So that's why it doesn't matter whether you pick x or y, because we had to multiply both of them by the same thing. Then we're going to set up a ratio and simplify. So I go to s prime, and I find my x value, which is 5. I go to s, and I find my x value, which is 2. I go to s prime, and find y, which was 10. And then I go to my pre-image, which was s, and find my y value, which was 4. If you simplify this, 5 over 2 becomes 2.5. 10 divided by 4 also becomes 2.5. Or you could leave it as 5/2. So when you write this algebraically, this means that I took each x value, which was 2, and I multiplied it by 2.5 to get my prime. I took each y value and multiplied it by 2.5 to get my prime value. So my algebraic, you can write it one of two ways. You can write it as 2.5x, 2.5y. If you want to leave it as a fraction, you could leave it as 5/2 x, 5/2 y. It's the same thing. All right, so let's try. I'm going to show you. I'll do 2 of them, and I'll do 2 of them, and you can do 2 of them. So we got to find our scale factor. So these ones, you'll notice I don't have like my vertex. I have r and r prime, but they didn't label my vertex. So I'm going to look at this point right here, which means I need this point right here. So I'm going to take r prime and put it over r, and I'm going to choose my x values. It does not matter. So x prime on top, x on bottom. So my x value for prime, and again, nice clean copy. This is my pre-image, this is my image. So you should be able to tell that it shrunk. It got a lot smaller. We need to figure out how much smaller it got. So I'm going to take x prime, which is 1, and I'm going to take x for r, which is 5, and then I'm going to simplify. You can leave it as 1/5, or you can put it as 0.2. Either one will work. So you could put 0.2 or 1/5. So when we rewrite this, you could write it as 1/5 x, meaning 1/5 times x, 1/5 times y, or if you wanted to leave it as a decimal, you could leave it like that. They mean the exact same thing. This one right here, this image math, is exactly what we did up here. So I'm going to leave that one for you to try, and then I'm going to show you one more, which is this one, and then you can do these 2 on your own. So again, I need 2 points. So I'm going to choose C and C prime. Those are the ones I'm going to pick. So prime on top, image on top, pre-image on bottom. And so then I start, and this time I'm going to just pick y, because it does not matter whether I choose y or x. My y value for C prime was at -4. My y value for C was at -2. So when I simplify this, I'm going to get 2. So my scale factor is 2. Algebraic rule, 2x, 2y. So take 2 times each x value, 2 times each y value to get your new points. All right, try these 2 on your own.